Azaan.
Yes, sir.
Uh, uh, I discussed in the last class the potential difference and
Yes.
the electric potential. So we discussed this electric. What is electric potential and what is the potential difference? And there is a relation between the potential difference, work, and the charge. So potential difference is equal to work done divided by the charge. And also I told you that means why you are doing this work, okay, and what is this charge and what is the potential difference. Earlier we discussed, okay, so and I think we discussed this also. Uh, for example, for measuring the length or height, there is a requirement of some type of scale. In the same way, to measure the potential difference, uh, there is a requirement of a device that is voltmeter. Okay. Voltmeter is used to measure the potential difference. Okay. And remember, voltmeter is connected in parallel always, and voltmeter have high resistance. Okay. Uh, this is one point. This is another point. In between uh, this point, A and B point, there is a bulb. Okay, this is the bulb, and this bulb is glowing. And you want to measure the potential difference between the point A and B, or you can say the potential difference across the bulb. So what you will do, you will connect a voltmeter here. Okay, you will connect a voltmeter here like this. Okay, this is the parallel connection. I will tell you why this type of connection is known as the parallel connection. Because in parallel connection, the potential difference remains same. So that we will discuss when we will study the series and the parallel combination of resistances. Okay. So this formula, remember this formula. Potential difference V is equal to work done divided by charge. Okay. And talking about the unit of potential difference, unit of potential difference. So the unit of potential difference is volts, SI unit, okay. And for the work done, W is the work done. So the unit of work done is joule. And this is the charge. This is the charge. And the unit of charge is coulomb. Unit of charge is coulomb. And joule we will represent with J, means capital J. And coulomb we will represent with C, capital C. And volt we will represent with capital V sometimes. And we can sometimes write volts also, and sometimes we can write this also. Okay, so potential difference is equal to work done divided by the charge. Okay, so uh, question number this. They are saying state the relation between the potential difference, work done, and the charge moved. So simple relation between the work done, potential difference, and the charge moved, that is equal to potential difference V is equal to the work done divided by the charge. Answer B. Calculate the work done in moving a charge of 4 coulombs from a point at 220 volts to another point at 320 volts. They are saying there are 2 points. Suppose this point is A, this is B. 2 points are there. At one point, the potential is 220 volt. Means potential at A is equal to 220 volt. Potential at B is equal to 230 volt. And a charge is there, 4 coulomb charge. Suppose here is a charge of 4 coulomb. And this 4 coulomb charge, you are carrying this 4 coulomb charge from point A to point B. Okay, you are carrying a charge of 4 coulomb, or you can say you are means this charge is moving from point A to point B. So how much work you have to do to move this charge? So when you will move this charge from this point to this point, okay, then how much work you have to do? So simply you can just apply the formula, potential difference is equal to work done divided by charge. So potential difference is equal to work done divided by charge. So potential difference, they are asking potential difference. So the potential difference between the point A and the point B, potential difference. So at A the potential is 220, at B the potential is 230. So potential difference will be potential at B minus potential at A, that is equal to the work done divided by charge is 4 coulomb. So put charge as 4 and VB minus VA, VB minus VA 230 minus 220 is 10. 230 minus 220. This is equal to work divided by 4. So here it will be 10. This is equal to W divided by 4. So work done, you will get 40 joule. 40 joule of work we have to do in moving a charge from point A to point B. Okay, so this is a question from NCERT. They are saying how much energy is given to each coulomb of charge passing through a 6-volt battery. Passing through a 6-volt battery. How much energy is given to each coulomb of charge passing through a 6-volt battery? So the concept of battery I will tell you later. Means after this topic we will discuss why we use battery. Okay, whenever it is given in the question 6-volt battery, this is given a 6-volt battery. So 6-volt battery means or you can say 6-volt battery means there are 2 terminals in the in battery. Means in battery there are 2 terminals. One is positive terminal, another is negative terminal. So 6-volt battery means the potential difference between the terminals of the battery is 6 volt. Okay. So in this question the potential difference is given indirectly. 6 volt. And they are saying How much energy is given to each coulomb of charge? Each coulomb, what is the meaning of the each coulomb? You will take the charge of 1 coulomb. So charge of 1 coulomb you will take. Each coulomb means 1 coulomb. For every coulomb of charge, how much energy spent? Okay. So how we can relate it with the work? Uh, First we will calculate the work. Okay, because we have this formula: potential difference is equal to work done divided by charge. So potential difference is 6, work done, charge is 1 coulomb. So work done is equal to 6 joule. Work done is equal to 6 joule. 6 joule. Now talking about the energy, if there is some battery and of 6 volt, and the charge is passing through that battery. Okay. So basically, for passing the charge through the battery, you have to supply the electrical energy. You have to supply the electrical energy to the battery. Okay. Then only there will be the flow of the charge. And while the electrical energy supply you are supplying to the battery means you are doing the work. Okay. Means you are doing the work. Okay. So basically you can say the amount of work that you have to do is equal to the energy spent or energy given to every coulomb of charge. So energy will be work done that is equal to 6 joule. That is equal to 6 joule. Azaan, understanding?
Yes, sir.
Okay. There is one more same question there. Means little changes are there in the second part. The data is changed, but otherwise the question is same. First part of this question: name a device that helps to measure the potential difference across the conductor. So we know what is that device: voltmeter. Answer B. They are asking how much energy is transferred by 12 volt 12 volt power supply 12 volt power supply to each coulomb of charge which is moved around the circuit. Okay. How much energy is transferred by 12 volt power supply? So 12 volt power supply means you can say power supply is, you can say this 12 volt power supply means the potential difference is given. The potential difference of that power supplied source means power supplying source is 12 volt, and each coulomb means I told you you will take charge of 1 coulomb. You will take charge of 1 coulomb. Then you will calculate the work here, and that work will be equal to the energy transferred. Energy transferred by the battery to the charge. Here also actually I told you na, you have to means you have to supply the electrical energy. I mean to say that this battery will supply the electrical energy to the charge so that the charge will move around the circuit. So circuit we will discuss later. So when we will discuss circuit and potential difference and all that, then more clearly, you will get these points. Okay. Please note down. Done.
Yes, sir.
Okay. So so there is no requirement of noting down this question because you can do it same as this question. Now we will discuss the electric current. Now before the electric current, I want to tell you something. Uh, Basically, the electric current is just like the flow of the water in a pipe or flow of water, you can say. Um, See, suppose this is some. This is some surface. This is the point A, and this is the point B, and this is the ground. This is ground. This is some type of surface, and this A is at higher height and B is on the ground. You can take another point also, C. C is little up the ground. This is at height h1, and this A point is at height h2, and h2 is greater than h1. Okay, so tell me one thing. If you are, if I will say that water, okay. Uh, so the water will flow in this way on this surface. The water will flow A to C or C to A. Naturally, the water will flow A to C or C to A.
Yes, sir.
I'm saying on this surface, the water, if there is water, then the flow of the water will be from A to C or C to A.
Sir, A to C.
A to C. Means what you are saying, the water will flow from higher height to the lower height.
Yes, sir.
Water is flowing from higher height to the lower height. Okay. Now see. Now we will discuss our topic. Suppose this is a conducting wire, and I am taking 2 points on the surface of the conducting wire, A point and B point. The potential of point A is VA and potential of point B is VB. Okay. Potential of A is greater than the potential of B. Potential of A is greater than the potential of B. And I told you in a wire or conducting wire, what happens? There is a flow of charge. I told you there is a flow of charge. And or I told you that in the conducting wires or in the conductors, the charge can flow. The charge can flow. So like here, na, water is flowing from uh, higher height to the lower height. In the same way, uh, charge always flow from higher potential to the lower potential. Charge always flow from higher potential to the lower potential. So the flow of charge will be in this direction. The flow of charge will be in this direction. Okay, getting or not?
Yes, sir.
This is the analogy, na? Means you can relate it why charge always flowing from higher potential to the lower potential. So reason is simple, because here if the water will be at point A, and if the water will be at point C, so you can say at point A there is the maximum instability, and at point C there will be some little minimum instability. So instability, or you can say it is a potential energy at A is greater and potential energy at C is lesser. Okay, so leave that. Basically, remember, charge always flow from higher potential to lower potential, and and flow of charge is current. Flow of charge is current. What is current? Current is the rate of flow of charge. See, this is a wire, point A and point B. A point is at higher potential, B point is at lower potential. So the charge will flow from A to B. Okay, charge flow from higher potential to the lower potential. Now, what is current? Current is basically nothing but the rate of flow of charge. means in a particular amount of time, how much amount of charge is flowing is basically the current. Okay, so current is rate of flow of charge, and we will represent current with capital I. And current is equal to charge divided by time. Current is equal to charge divided by time. Like speed is equal to distance upon time, na? What is speed? If I will talk about the speed, so basically speed, the rate of covering the distance. How fast you are covering the distance is the speed. Is it or not? Like the current is charge, means how fast the charge is flowing is current. So current, when you will calculate the current, or you can say the formula to calculate the current is equal to charge flowing divided by the time for which the charge is flowing. Okay, so current I will represent with capital I, charge I will represent with small q, and time is small t taken here. Now talking about the SI unit of the current. So SI unit of the current is ampere. Okay, SI unit of the current is ampere, and if you want to measure the current in a wire or anywhere, so there is a device ammeter. Okay, in your lab you can see this. If you have a lab in your school, then you can see this type of device will be used to measure the current. So current is measured by the ammeter, and always ammeter is connected in series. Always ammeter is connected in series. See how the ammeter is connected. Suppose in this wire there is some current flowing. To calculate that amount of current, you will connect an ammeter. This is a symbol of ammeter. Okay, so you will connect the ammeter like this with wire, and the reading on this scale, the reading on this scale, this is the pointer, and this is a circular scale. So this pointer will point out some value, and that value will be the electric current, amount of electric current, like 2 ampere, 3 ampere, 4 ampere, 10 ampere. So in this way you will connect the ammeter in the to measure the current. Okay, and one more point, ammeter should have low resistance. Ammeter should have low resistance. Now, what is the reason ammeter should have the low resistance? Because uh, ammeter is measuring the current. Ammeter is measuring the current. If the ammeter, this is the ammeter, if this ammeter will have the high resistance, then the current flow in the ammeter will become less. More will be the resistance, more will be the resistance, less will be the current in that device. So for getting the accurate value or the correct value of the current, or for the correct measurement of the current, this ammeter should have the low resistance, so that the maximum amount of current should flow in the ammeter. Okay, and you will get the correct reading. Getting or not?
Yes, sir, I'm getting.
Okay, so please note down. So remember why there is a current. You can just ask me someone why there is a current. Current is due to the potential. Current is due to the potential difference, and current is nothing but the flow of rate of flow of charge, like the flow of the water. You can say there is a flow of water also, and there is a flow of charge in the wire. And the flow of the charge in the wire is current basically. Okay, so write down. When completed, you can ask me to scroll down. Okay.
Okay, sir.
Scroll down.
Yes. Then scroll down, please.
Okay. Completed this one.
Yes, sir.
Okay. So tell me why emitter should have low resistance. Hmm? Why emitter should have low resistance?
Like to avoid.
Hmm. Means simply you can say the emitter should have low resistance so that the maximum amount of current can pass through the emitter or can flow through the emitter so that the accurate reading of the current it will give.
Okay, sir.
they are saying an electric bulb draws a current of 0.25 ampere for 20 minutes. Calculate the amount of electric charge that flows through the circuit. Calculate the amount of electric charge that flow through the electric circuit. So in this question, what is given? The value of the current is given. And this current is flowing for how much amount of time? For the 20 minutes. This is the value of the current for 20 minutes. So they are saying calculate the electric charge, the quantity of the electric charge that flows through the circuit in 20 minutes. Okay. So there is a relation between the current, charge and time. So current here given 0.25 ampere. Time is given as 20 minutes. Now SI unit of time is second. So we will convert the minutes, 20 minutes into second. So we will multiply 20 with 60. So what we will get? 1200. 1200 seconds. Charge you want to find, means they are asking what amount of charge will flow through the circuit in 20 minutes or in 1200 seconds. Apply this formula. Current is equal to charge divided by time. The value of the current is 0.25. Value of the charge is, you have to find, and time is 1200 seconds. So the value of the charge will be 0.25. 0.25 means 1 by 4. Okay. When you will remove this point here it will be 100. When you will cancel this out, it will become 1 by 4. Okay. So 0.25 means 1 by 4 multiplied by 1200. The charge flowing is 300 coulomb. So this amount of charge is flowing through the circuit, 300 coulomb in 20 minutes. Okay, so note down. Done?
Yes, sir.
Okay. So charge always flows from higher potential to the lower potential, from higher potential to the lower potential. But there is one more point here. The charge always flows from the higher potential to the lower potential till the potential of 2 points become same. Okay, the charge flows from higher potential to the lower potential till the potential of 2 points become same. And suppose the charge is flowing in a wire, and the 2 points of the wires are at different potential, means there is a potential difference between 2 points on the wire. So there will be a time when the flow of charge, okay, due to the flow of the charge, the potential of point A and potential of point B will become same, and the flow of charge will stop. If the flow of charge will stop, means there will be no current in the wire. But what we want means we are using n number of things. We are using laptop, we are using mobile phones, different things we are using. So in those type of devices, there is a continuous supply of the current. There is a continuous flow of the charge. So for the continuous flow of the charge or current, what we have to do, we have to create permanent potential difference, so that the charge should flow. So for that purpose, we use cell or battery. So what is the use of the cell or a battery? Basically, the cell or a battery creates the potential difference, and that potential difference is permanent potential difference. Continuous. Permanent means until then the battery or the cell is getting discharged. So here is the next point: how to get the continuous flow of the current. So for example, continuous flow of the current means, if you are running, if you want to run any type of device, okay, just for example, you can say laptop and mobile phones and all that. So these are the continuously using devices, usable devices. So for these types of devices, there is a continuous uh, flow of the charge, and for that continuous flow of the charge, there should be a continuous potential difference, so that the charge will flow. So for that purpose, suppose this is a bulb here. Okay, this is a bulb, and this bulb is connected by the two wires, and these two wires are connected with the two terminals of the cell. So this is a cell of 1.5 volt. So what is the meaning of this 1.5 volt? This 1.5 volt is representing the potential difference between the positive and the negative terminal of the cell. So this is the potential difference. If you will connect one end of this bulb with the help of the wire to the negative end, another end of this wire with the positive end, so what will happen? There is a potential difference created at the ends of the wire. Here, this point of the wire will be at the negative potential of some value. This point of the wire will have the potential positive potential. So there is a basically potential difference due to this cell, and then the current will flow. There is a flow of the electric current, and this electric current will be continuous, because here this potential difference will be due to the cell. Until and unless you are not removing this cell, this potential difference will be continue, and there will be the continuous flow of the current also. So if there is a flow of the current, then there will be the bulb lights up for the amount of time this cell is working properly. Okay. So the use of the cell of the or the battery is to create the potential difference. So you can just draw this diagram like this. This is a bulb, and you have connected the bulb with, and this is the symbol of the cell. You have connected the bulb with cell like this, so that there is a continuous flow of the current and the bulb will glow. Okay. So the simplest way to maintain a potential difference between the two ends of the conductor, so as to get a continuous flow of the current, is to connect the conductor between the terminals of a cell or a battery. Why we are connecting a cell or a battery? The main reason is to create the potential difference between the ends of the wire. If there will be the potential difference, then only there will be a flow of charge, then only there will be the current, then only the device will work. Getting or not?
Yes, sir.
Okay. So the main reason why we are using cell or a battery is to create the potential difference. If there will be a potential difference, there will be the flow of the charge. If there will be the flow of the charge, then you can say there will be the current. And if there will be the current, then the device will work continuously. According to our requirement, the device will work. Means, okay. Okay, so now just draw this diagram, and um, if you are able to draw this diagram, then you can draw this instead of this. If you are not able to draw this diagram, then you should draw this. So here this cell is used to create a potential difference. This cell is basically a dry cell.
Done, sir.
Done out. Write on this. And do you know what are the redox reactions?
Sir, I know, but I don't remember it.
Okay, okay. Uh, just knowing is okay. Uh, this is a cell, na? Basically, this cell works on the redox reactions. So there are some redox reaction taking place inside this cell. Due to that, uh, this terminal of the cell becomes positive, and this terminal of the cell becomes negative. So this is a cell. Inside the cells, what is taking place? Redox reactions are taking place. Okay. So due to those redox reactions, there is a potential difference of this 1.5 volt.